I thank the organizers for this great event, and I hope that you will enjoy my talk, which is maybe new, because this model, I've been working on it for more than 30 years, but mostly this duality of time theory is more recent. So this model is actually very deep in history. If you look back in the philosophy, ancient philosophy, many great philosophers have thought that eventually the cosmos is one, and there is no real motion and no real multiplicity. So everything must be made from one. This oneness is the single monad. Maybe I'll explain more about it in a moment. But my work in this subject is really the duality of time concept, which provides a tool that explains how this multiplicity that is clearly visible, and we cannot deny it, how this actual multiplicity is emerging from pure oneness, metaphysical oneness. So this is abstract. I will not read it all, but only I want to show here that you will be surprised that these basic equations that we use in classical mechanics can be used to derive, and literally I mean derive, the principles of relativity, including the constancy and invariance of the speed of light, as well as symmetry of physical laws. All this possible only when we take into account the duality of time theory and the recreation principle that is one of the main principles of the single monad model. And then I will be deriving, I will show you how we can derive these principles in addition to another principle that allows or show us the discrete symmetry of space. Because until now, we know that relativity is based on continuous space-time. So it is not quantum, but with the recreation principle, it will become granular, the space-time will become granular, and therefore I can call it quantum relativity. Hopefully you will be convinced with it. So I will be giving a quick introduction to this single monad model and duality of time postulate. And then I will move very quickly. Usually, actually, I take more than half an hour to introduce this model, but I don't have time for that. So if you like, you can go to my website that is shown at the end here. Everything is given in articles and some other videos. So I will move, after the introduction, I will move very quickly to the practical derivations. So I will be deriving the principles of relativity, as well as I will show how we can derive supersymmetry from, not derive, I mean the concept of supersymmetry, from the same equations, that is the classical equations that I showed before. Additionally, also we will see two more levels of symmetry, that is hyper and ultimate. Because if you think about the basic idea of this single monad model, it actually means absolute symmetry, because eventually it means that there is no real motion, no real multiplicity. So there is ultimate or absolute symmetry. So the highest level is ultimate symmetry, and then we have hypersymmetry that is like a conversion between the ultimate and the deformism or the curved space-time. And then the lower level, supersymmetry and normal symmetry, are the granular space-time and of course physical objects. And then also I will be showing some derivations of the equation, main equation, that is E equal mc squared, in different methods. All this is only possible with the duality of time theory, because until now there is no full derivation of this equation. And along that, I will be showing also how mass is generated, and therefore what is the basic fundamental reason why we have mass at all. In addition also to explaining the Mach principle, which was the main motivation behind Einstein when he developed his theory of general relativity. So as you can see, a lot of things to talk about. I hope that time will be enough. But let me very quickly introduce the idea, the main idea. So it is the single monad model, and it has been attributed to some philosophers, mainly Plotinus, that from the one who is eventually the creator of the universe, who is absolute one, only one can proceed. Because if you imagine multiplicity emerging from one at the same time, then the original one must be composed in itself, because it must have different faces to different entities. So in order to accommodate this, this model that I'm working on is actually based on al-Arabi, who is a famous Sufi master. And by the way, he was born in Murcia, but not very far from here. So he is about 800 years now. So his ideas, his books, I actually took all these ideas from his books. So he only add to this maxim, from the one, only one can proceed, but at a time. So in our normal time, clearly we see many things, but in the actual flow of time, only one can flow or can proceed from the one. And therefore, this can be demonstrated with this figure, where you can see the monad. So maybe you will ask, what is the monad? Of course, this is not easy to explain, but let me, for simplicity, tell you that the monad can be thought of as a simple geometrical point. But in reality, it's composed in itself, and it's like a black hole. It's from outside, it's a singularity, but it's from inside, it's a complete cosmos, because the monad is active and creating. So it's not a really simple point, but from our point of view, it is a simple point. So this monad is going in the inner levels of time. So this is the meaning of duality. We have outer levels that I will explain in a moment also, outer level and inner level. So in the inner levels of time, this monad is creating a whole frame of space, including the 3 dimensions, and then this is recreating. So every moment of time, there is a frame of space. So there is no actual motion, no transmutation. When I am moving, for example, usually I think of myself as I am carrying myself and then moving through space-time. And this is not what the reality is. The reality is that there is a frame of space, and then another frame, and then another frame. So there are actually no actual motion. There are only changes. We usually approximate this change into continuous motion, and that's why we get general relativity that is based on continuous space-time. But in reality, when you take into account this recreation, you will discover that space-time is really granular and quantized. So I got all this, as I told you, from al-Arabi, but I will not be able to really explain all his ideas. Only I want to show you this statement. He says that the cosmos is imaginary, yet it is in reality real. So on the outside, the cosmos is imaginary, it's only illusion. But in the reality, it's real. So from this real, which is a single monad, these different forms are appearing. And when you understand this, you will be able to really understand the reality. And that's the meaning of the duality of time. So the duality of time postulate, which I introduced, can be summarized in the following statement. So we can say that at every instance of the outward normal level of time that we usually feel, which is like the moment now, at every instance, the dimensions of space, including matter, because you will discover after a while that with this, the vacuum becomes physical, and therefore physical objects like electrons, protons, etc., are actually only excitation of this vacuum. So when at every instance the space is being recreated in chronological order, chronological sequence, this sequence forms the inner levels, and we have actually 6 levels of time in the inner, which are the 3 dimensions. Every 2 levels of time make one dimension of space, and therefore in total we have 6 times 3 space. So these inner dimensions, these spatial dimensions, are created in one single sequence, which means that in the reality of time, in the real flow of time, there is only the monad, and therefore with the flow of time, space is created, and then with the flow of the outer time, the the change, which is the motion, what we describe as motion, is occurring. Therefore, this is demonstrated with this frame. So we have frames that are only moving continuously, granularly, one frame at a time. And therefore, if you stop time, like in the outer time, if you stop it, you will see a frame of space. If you stop the real flow of time, you'll only see empty space that is really nothing, or the single monad itself. So therefore, this flow of time in the inner and outer together is hyperbolic. And therefore, we get the relations that is basically the root of Lorentz transformation. And from here, we can get all the laws of relativity. But here I want to add, since time is really very short, I want to show that the speed of light in this case, because now the inner time is made, because the space is now made in the inner time, so the speed of light is no more space over time. It's actually time over time. So it becomes unitless if you know exactly how much time, how much space is created in every moment of time. So if you can convert space into time in the inner level, it becomes time over time, and therefore it becomes unitless. And therefore this becomes actually equivalent to the dimensions of geometry, or the fractal dimensions of geometry. And that's why it's actually constant and invariant. So in reality, when you are moving in the outer time, you don't you are moving in a direction that is perpendicular or orthogonal onto space, no matter how you think of space in 3 dimensions. So always you are moving orthogonally in relation to space, and therefore the speed of creation, that is the speed of light, is constant and invariant, no matter, it's not affected by your own motion. To give you an example, this screen that you see in front of you, if it's like a computer screen, we know that it's actually not real. There are no real objects on it. And if something is moving on this screen, it's actually moving not because it's moving, it's transmutating, it's not carrying itself and moving, but it's frame by frame. Sometimes it appears in one place, it appears in different place. So if it's smoothly moving, we can then understand how motion is occurring. And therefore, this actually solves many problems, but I will not have time to demonstrate all of them. For example, non-locality can be explained very easily, because since it's only refreshing, the object that is like in the ABR experiment can appear in one place at one moment, and then in another place at different moment, regardless of the distance between them. This same idea actually also explains, for example, one fundamental problem, that is a homogeneity problem, because we know that the cosmos is very big and yet it is homogeneous. So how come these different areas of the universe are interacting, although the distance between them is very big? So with the refreshing, with the inner time, this can be understood. In addition, actually, to many other problems that I will not be able to explain this, since time is running out. So I hope that this can give you the motivation to read more about this model. Please visit my website and see more details with articles and books that can be downloaded. Good. Thank you very much.
So, 3 months for quick. Any questions? Then I have a question. So, are you involved with this formalism of providing some justification to find that the relativity of the imaginary time related to the temperature of quantum system, and also to that of the quantum operation and so on? Are you involved with providing some interpretation to this?
Sorry, say again, this last thing.
Yes. Are you involved with this formalism of providing an explanation of or the fact that they exist on the imaginary time corresponds. Imaginary time corresponds to the temperature of quantum field theory and so on.
Yes. So actually, I really skipped many derivations here, but if you follow the derivations, you will notice that like for example in this figure here, if you think in the inner time, we have no physical objects, only the monad, that is only a simple point. So it only moves between 0 and C. So this makes the background that is real a vacuum. It has a structure because it has levels, and there are actually three different. There are 2 arrows of time because they complement each other. So we have like real time and imaginary time, and then another structure that is actually correspond to the psychical world. So we have the physical and the psychical. Together they make a full symmetry. So by breaking this symmetry, we have our physical world. It has different levels of vacuum. So we can think of three possibilities of the flow of time. Either the outer time is faster, and therefore we have the psychical world, or the outer time is slower than, which is our physical, our normal world, or they are equal. When they are equal, we make a new dimension. This new dimension has a zero when the outside velocity is 0, so it is a vacuum. So this vacuum can be excited. So all our physics that we study is excitation of this vacuum. You can think, for example, of temperature. You can think of atomic particles. All structures are excitation of the vacuum, physical vacuum.
I see. Okay. Are there any more questions? Doesn't seem to be the case, so let's start our speaker again.
Okay.